Welcome to aminacademy.com. In IB Diploma Mathematics, let us discuss about algebraic operations with 3D vectors. Look at here. Let vector A, the component A1, A2, A3. Vector B, B1, B2, B3. And vector C, C1, C2, C3. Now, vector of this addition is possible. A vector plus B vector is adding the components directly. A1, B1, A2 plus B2, A3 plus B3. Also, we can find vector A plus vector C, vector B plus vector C, adding with these vectors possible now. Now, subtraction. Vector A minus vector B is the component is subtracted, that is B minus A. B1 minus A1, B2 minus A2, B3 minus A3. Components are subtracted. Then here next vector of K times vector B. Suppose K times vector C is what? That means K is any constant scalar. Then A is equal to K times C1, C2, C3. Means the components are, each components are multiplied with K, which gives KC1, KC2 and KC3. Now addition is commutative. Now look at here. Vector A plus vector B is equal to vector B plus vector A. Addition is commutative. Then associative also possible. Vector A plus vector B plus vector C can be written as vector A plus vector B plus vector C. Its addition is associative. Now next one, vector A plus 0 vector is equal to 0 vector plus vector A is equal to vector A. Now vector A of negative of that same vector A adding is 0 vector. That means you can write further minus vector A plus vector A is equal to 0 vector. Now solving some problems, right? Look at here. Solve 3x minus 3x minus s vector equal to r vector. How to find x? Find x. Find x vector. Here first 3x vector is equal r plus r vector plus s vector. Then x vector is r vector plus s vector by 3. This is like simple algebra. Now one more. Look at here. This is, suppose some points are there here, equal points. the point A is -2, -5 and 3 suppose, and point B this is a point B is -1, -2 and 2. This is a point C and point D is here. Regarding this line space, we have to write some questions here. What is, in this we have to find the coordinate of, find coordinate of the missing coordinate, suppose this C and D. Here all are equal spaces here, then A and B is equal to B and C equal to C and D. In this, you have to find the coordinate of C and D by using these conditions. First, you have to find vector AB. Vector AB means use these 2 points, and first vector AB is -2 -1 -2 -1 -1 minus of -2 -2 minus of -5 and 2 minus 3. Here this one is -1 plus 2 is 1, -2 plus 5 is 3, and 2 minus 3 is -1. This vector AB. Now, from position vectors, OC, vector OC, O is the origin, OC equal OA plus AC. Additional rule, we can find OC. O is some imaginary point here. OC is OA plus AC. OA is this A point. OA is -2, -5 and 3 plus AC. AC is from this to this, but OC, we don't have the point of C, but B is the midpoint of AC. Therefore, instead of AC, we can write vector 2 times vector AB. 2 times vector AB. Here, look at here. This B is the midpoint of A and C. So we can say vector AC is 2 times vector AB. 2 times AB is already we have 1, 3, -1. So we have here -2 plus 2 is 0. -5, 2 into 3 is 6. -5 plus 6 is 1. And 3 minus 2 is 1. This is vector OC. And you have to find this is, therefore OC is this one, therefore the coordinate of C is 0 because it's OC, O is the origin, so it is 0, 1 and 1. Here similarly we can find vector D as follows here. Look at here. OD, vector OD is equal to OA plus AD. Here, OA is, we have already 1, 3 minus 1. OA, vector OA is minus 2, minus 5, 0. Minus 2, minus 5 and 0. Since here, here that point A is given this one. So from this we found vector OA. Then AD, look at here, AD is 6 spaces from A, that is, we can say AD is 3 times AB. 3 times AB is already we got it from this one, 1, 3 minus 1. 1, 3 minus 1. So we can calculate. Here minus 2, 3 into 1 is 3, so it's 1. Then next is minus 5, 3 into 3 is 9, 9 minus 5 is 4. Then 0, 3 into minus 1 is minus 3, 0 minus 3 is minus 3. One, 4 and y equal to 2 minus 2, 5. Minus 2 minus 5, y is 3 here. This is 3, not 0 here. Then 3 minus 3 is 0. We got vector OD. Therefore, then coordinate of D is 1, 4, 0. Here, another question. Use vector example. Use vector to find ABCD is a parallelogram. ABCD is a parallelogram. How to prove this? Suppose a point A is given 3 minus 1, B is 4, 2, and C is minus 1, 4, and point D is minus 2, 1. Here, let us draw one parallelogram. Suppose we keep this a parallelogram, it's a quadrilateral, and we have to prove this a parallelogram. A 3 minus 1, B is 4, 2, C is minus 1, 4, and D is minus 2, 1. Here, to prove this as a parallelogram, so we have to find this vector AB is equal to vector CD. That means both vectors are equal vectors. So vector AB is B minus A, that is 4 minus 3 is 1. 4 minus 3 is 1 and 2 minus 1 is 1. Then AB vector as well as AB and DC is equal minus 1 minus of 2 is 1 and 4 minus 1 is minus 1 of minus 2 AB we found. AB is what? 4 minus 3 is 1 and 2 minus of 1 is 3 here. 2 minus of minus 1 is 3. Then DC is equal minus 1 minus 2 is 1 and 4 minus 1 is 3. So here the vector AB is parallel to BC first. Here you can find AB parallel to DC, as well as you have to find the distance, magnitude of AB. Magnitude of AB is 1 square plus 3 square equal square root of 10. And magnitude of DC is equal same as 1 square plus 3 square equal root of 10. From these two things, that is AB is parallel to vector AB is parallel to vector DC, and length of vector AB is equal to length of vector DC. From this condition, we can say opposite vectors are equal vectors. Similarly, you can prove this opposite AD, vector AD equal vector BC. Also, we can prove similarly vector AD is equal to vector BC. Vector AD is equal to vector BC. Both vectors are same vectors by using same method as follows here. Then we can say ABCD, quadrilateral ABCD is a parallelogram. So far we discussed about algebraic expansion, that is algebraic rule for vector in 3 dimensions, algebraic properties, algebraic operations. We have done. Please subscribe our YouTube channel.